Hello everyone, this is Bradley. So in the past, I need a hand fan. So I did this in animation nodes because not only it's easy to model, but also the UV texture problems. However, these days, since we have new attribute transfer nodes, I think we have more powerful ability to do various functions. So I think it should be possible in geometry nodes to really complete the whole project without any problem. So I think let's start. So the first thing we need to do is to go to the edit mode and enable an add-on which is called extra object. This comes with Blender, so just search that and enable that, it will be just fine right away. This is not really mandatory. The whole point is that I need a single vertices to start with. So I plot these single vertices into the quick favorites. Usually this is also very helpful when you only need a kind of object to hold geometry nodes modifier. Maybe your geometry node is referencing other objects or other collection. But in this case, we still need a single vertices because we're going to extrude that out. Where's that? Screw modifier. Screw modifier, screw modifier. Where's the screw modifier? Yes, screw modifier. So this is kind of very interesting part. The screw modifier, maybe you usually just think to make a kind of a spiral screw shape, but if you just scroll on and access, then it actually determine it will actually extrude the point for you. Then we're going to duplicate this screw modifier, and I'm going to change the axis into Z. In this case, I'm not going to screw any meters, so that it will just on a plane, but I'm going to change the angle so that we know where I'm rotating with. So everything is kind of negative. Okay, so now we basically have a fan, although there is no folds. There are several things I want to remind you is its wireframe. So in the first screw modifier, in which we're extruding a single vertices, the step is essentially determines how many cuts or subdivision within these polygons. I will keep them as 1, 1, so that it's easier to control. Otherwise, I probably just run crazy. The second step is also very important. It determines how many subdivisions horizontally, so that how many polygons you have. Maybe you want to have a dense fan, but in such a kind of case, you also should realize that the fold will be very tiny. It may not be very interesting. Just a kind of suggestion. So in this case, I'm just going to take the 12, 12. I think should be a good number. Okay. And definitely just controlling this angle is essentially how much you control the expansion of the fan. Okay. So let's add a geometry nodes modifier. Okay. So, and then goes to noding. In the past, we do not have any controls with the indexes numbers. So that at the time that I want to elevate the every second edges or every second points, I have to use a dumb workaround that calculates all the kind of degrees on the plane or other things, use arctan here. But nowadays, since we started to have this index control, we no longer need to do this kind of horrible workarounds. Instead, we can just directly use this index. So here we have the set positions. I'm going to take the combine XYZ, set that to 0, 0, 1. So that all the points should lift up, and once we plug that into position, everything has been disappeared because all the vertices location has been crashed into 0, 0, 1. But once we add offset, it will add our position to the original position attribute, so that all the points will be elevated by 1 unit. Next thing we are going to do is to deal with the selection so that every second vertices has been moved. And I've created a preset which is called the index mask fourth, basically to mimic the effect or replicate the effect for the one from the animation nodes. So every second vertex should be affected in this particular case. So we take the mask into the selection. However, it does not really work. Here I do realize the problem that this is not really a fan. The reason this is not work or this point has been elevated is because it seems like there's 1 point, but there are actually 12 points. So every second vertex is here. Another reason it does not really work is the way we construct this entire mesh is using the skew modifier. So the indices number may not be the same as the one that is produced by the animation nodes. So let's convert to mesh, and here we can actually view the indices number, and you can see the indices number actually goes 0, 1, 2, 3, 4, 6. So the every second vertices is this group. So how can we actually move these vertices and these vertices at the same time, these vertices and these vertices at the same time? Okay. So here, instead of using the preset that I built earlier, I'm going to do the math from scratch. So just to know that basically the way I build these presets is basically a modulo function. So actually that's it. It's kind of very simple. And the modulo function essentially will determine whether this is kind of odd and even number. However, since in this case we're going to isolate 2, 3, 4, 6, so 2 is even number, 3 is odd number, so we cannot simply use modulo. We need an operation to converge 2 and 3. In this case, it's just basically a simple math that we divide the index by 2. And let's take a float to integer. I need a floor. So in this case, 2 divided by 2 will be 1. 3 divided by 2 will be 1.5, and its floor will also produce 1. In this case, we're converging this value together, and the 4 will start to output 2. 5 will be 2. Okay, so in this case, after we're doing this operation and then we start to modulo about the 2, then it should start to work. Yes, immediately we have every second vertices being lifted up, and we can control the amplitude a little bit. Okay, so this is done. Next step is to add sticks. You can do everything more procedurally with primitive, but I'm going to do a little bit of dumb modeling. It's basically just to crush our cubes, and in the edit mode, crush our cubes. The whole point of this kind of stick is that I want to make sure this stick origin is on one end. Okay. And then I'm going to instance on each polygon. This is also kind of very interesting part, because how am I supposed to do that? So instancing on the polygon center, we can use the mesh to points and take the type interfaces. And here I'm going to take the attribute capture. I probably need attribute capture. I will see later. So here, let's take a join geometry, because I need both this stick and the fan that we generated. Actually, I still prefer wireframe, or probably viewport with wireframe. Yes, maybe this is better. Anyway, so once we have these cubes, I'm going to take these mesh to points and the point instance. Take the object info. I'm going to take the instances of our cube and plug that the instances. So now immediately we have all these kind of sticks being instanced in this place. I'm going to take a second. So let's take a index mask for, and I'm not sure if it actually works or not, but it seems kind of working. That's our sticks is generated every second point. Okay, in this case it works pretty awesome then. Or actually we can plug that into selection, doing essentially the same thing. Okay, so we do not need the attribute capture, which is good. So next thing that we need to do is to basically align all these kind of instances with kind of normal. And here let's take a normal attributes and align ruler to vector. And if we plug the normal to vector, rotations to rotations, and it does not work. It does not work. The reason is that the mesh to points The points does not contain any kind of normal other things because it can be faced to any 360 degrees within the space. So in this case, we have to go step before we actually converting into the points. We attribute transfer that, and then the geometry into target. So for transfer attribute, the target is actually the source where you want to pull the data. So that's the point. And the source position is really essentially the target, which how you want to evaluate that. Then you put the everything is into the stuff, and it does work, but it's very weird. We will discuss this later. Next, there's also another component of the rotation I want to discuss, which is the position. Actually, just by dealing with this, probably still have effect. No. Yeah, it's kind of weird. Anyway, okay. So if you plug the position into place, and immediately it will just rotate. And by changing this axis, you can see different effects of this kind of sticks in terms of the position. In this case, yeah, this is it. Basically, all this kind of align ruler to vector is comparing your vector to the world origin. So the world origin to the position may be this way, and this way. That's why when you switch to Y, it will align in such a kind of case. So here we are going to do a little bit of tweaking about how we would like each value to be changed. I think yes. Knowing that you're going to edit the first single vertices so that you expand it up. Okay. And then you can increase the size in the edit modes so that you do this. Okay. So here I'm going to lock or basically combine these two rotations together. Basically just plug the rotation to rotations and make sure that they actually align to different axes. Because I may elaborate this concept in the future tutorial, but the basic idea is that if you ask an empty to face on Z direction, then this is facing Z direction, but if you duplicate that and rotate that, this is also facing Z direction. So what I'm doing here is actually to lock another axis so that I make sure not only the Z axis is being aligned, but the X axis is also facing a specific direction, so that to make sure the rotations is actually accurate. But this does not really help very much. It's just the tilting the kind of cubes along with the normal. Maybe you like it, maybe you don't. But I think it actually makes a lot of difference instead of this kind of cubes just straight standing there instead of being tilting around along with normal a little bit. Okay, but there is definitely a little bit tweaking. I realize you probably would like to shrink its size a little bit, yes, to make it kind of really like a stick. The rest what you can do is just to take the translate instances and to move it a little bit and a little bit so that you hide them under the hood. Okay, so this is good. I think it's pretty okay. Here I do realize a problem, which is normally if you're looking at a fan, it's the last stick should actually stick out, and there should be a stick here. Okay, and it should be above the hood instead of under the hood. So I think there are many different ways to do that. One kind of cheating method in this particular case is I'm going to first delete the geometry, and I'm going to take the attribute statistics. So that take the geometry and the text index. And finally, I need to know the face count, so that I know how many face I have in this case using this maximum. And then I'm going to float compare and take that to the equal. So if the index equals to the largest face account, this face will be deleted. Okay, so we delete the last face. Okay, so now we have the last stick. This is kind of cheating method. But again, as I said, this is not the end because we still need to lift the last sticks up. Maybe you do not really care, but if you were to care that we are going to translate the instances using the selection again, we have to create a kind of mask for the last stick, sort of things. So once we have done that, we can start to test to fold this fan, and it seems pretty kind of working pretty well. There are some flaws that you can essentially realize, but this is also due to the mistakes I've done in the previous modeling. So you can remodel everything more carefully, and a little bit, yeah, something like that should be good enough. Okay. And there are many things that you can essentially tweak. For example, maybe for these rotations, I don't like it. Maybe I can rotate the instances. Make sure it's local transform and not this direction. Not this direction. Yes, this direction. Something like that. You can play around with a lot of things. So finally, to make it kind of more perfect from circumstances to circumstances. Yes. Roughly, this is kind of ideas. It actually works pretty well. Also notice that normally a fan, I think the last one should stick out. You have to use basically the same principle about the mask and then translate the instances. I will not do that here because I can expect kind of flaws that occurs once you fold the fan. Because if you local transform it, then this stick may just stick out from the plane, so you have to add more controls to do that. Then it will unlimitedly length this tutorial. So basically I'm telling you a rough idea how to model, but in real life, the more perfect or the more realism you want to add into your setup, the more controls you have to add, and then the more complex setup it will be. But for our fan, I think I'll basically, for the modeling part, I'll basically just stop here. Next step is I would like to talk about how to actually take on the texture, because this is kind of very important. So firstly, maybe I haven't mentioned, but if you're trying to create a kind of object or mesh within the geometry nodes, then adding a material is not the kind of perfect way to go, because I added a material, it actually works. It works for our fan, but not for our stick. So in such kind of case, you always need to set a material. I think sticks is the later one. So let's add a new material, because the material socket currently cannot create a new material as in animation. So you just add a new material. It's named as a stick, and then you can find a stick. You can just add whatever colors to that. It should be fine. Okay. So now we have the sticks. Okay. But dealing with our fans, if you would like to put an image texture on our fans, how are you going to do that? So we are going to basically copy the same method as I've done in animation nodes. Although because we're joining the geometry in this case, it might be a little bit different. But anyway. So basically the whole point is that I'm going to firstly try to expand the fan maybe 100 to a degree that in which you think is the maximum. So in this case, I'll probably just choose for 170, and then I'm going to duplicate. I'm going to apply this mesh. So right click, convert to mesh, so that I apply all the modifier. Actually, in this case, even the instance has been disappeared, which is actually benefits my wheelie. So in this case, I'm going to go through the UV editing and project from view. I probably use bounds. No, bounds is not very good. So project from views and then enlarge this texture. Okay, so now we start to have the UV of our fan. So this is what I really want in this case. So once we have the UV, let's go to the shaders, let's go to the materials, and I'm going to hit a Control T so that I have an image texture. Take the image from whatever places and then goes to the top view. Finally, goes to the eevee. So now we have a castle's image being posted on this mesh. Let's rename that as a UV. Goes to noding, UV editing. I'm going to rotate this a little bit. I feel like, did I actually project it in such a way? So let's reproject, make it looks kind of nicer. Okay, I think this is cool. So now we have a castles on the fan, which is also which is cool, but it does not contain any modifiers, so it cannot procedurally fold or whatever. But here's the case in which we're going to transfer this UV into the UV of our fan. So what we're going to do here is basically the transfer attribute and set the type into index so that all these kind of index match to each other. So this is one very important. So here we need to deal with UV, and in the spreadsheet you can actually see that UV is actually on face corner. We do not have UV because this object does not contain UV. So we need an object to contain UV. So once you add the UV map, then you can see the face corner. The UV map is a 2D vector and it's in the face corner. So we are going to transfer everything from the face corner to the face corner. And our target is, and as I said, it says target, but actually it means where you want to pull the attribute from. So I would actually call that source, but anyway, people call that target. What else I can do? So then this is vector, because we do not have vector 2D, so we have to use the 3D vector. Finally, plug this vector into the group output, because we do not have a set UV. Unfortunately, we do not have set UV node, which is a bummer. We neither have the UV attribute nodes. It's just have the UV sphere. Oh, this is crap. I think in the future it will change. So if by any chances we start to have the UV nodes, just like we have all the sound position nodes, please plug the UV node into these attributes. Now we have to use a little bit of workaround in this case. The workaround is basically just to plug everything into the group output, and everything's the attributes from the group input. This is the way. Take the attribute. Okay, so once we have that, I'm going to hit these cross buttons. Finally, take the attribute from the UV map and attribute from the UV map, output to the UV map. So here, I just want to a little bit explain the principle of the field. I've explained many times that this node by itself does not contain any information, and that's why the index in different contexts, like a different linkage, can actually mean completely different output. Okay, so this is very important. So this node does not really not contain any values, and especially it basically means nothing if it's not connected to geometry. This value will not be computed. So this value only, this node only means something when it's connected to geometry, and this node can mean different things if it's connected to different geometry. Okay, so this is the idea, which actually also means that in the old 2.93 and 3.0, you will see there are many nodes that you type the attributes, and we actually inherit the same workflow within this attribute for the moment, and it's basically the same process. This node is basically the same as just you type the index. Okay, so this is the point. This is the idea. That's why you can pull the UV map as a text from the group input, while it doesn't seem to make sense if you're just pulling the attribute from elsewhere and transfer it to elsewhere. Okay. If you do not understand it, it's okay. But now we still do not have anything. I have no idea why it does not really work. Actually, this really does not work, but I think we need to use the cycle. So then take a UV map and it does not work. Oh, what's the reason? So in this case, there are several things that we need to do. Actually, there's actually only one thing, because if you look at the spreadsheet, you can see there is nothing in the face corner. So goes into group outputs, you can actually select the domain that you pull the informations. and it still does not really work. Do we actually need to pull the domain? No, there's no domain. So for the output, we have a domains, face corner, everything's matching. Vector index face corner, which is okay. So why? Oh, yes, I need a cycle. It only works in cycle. Please don't ask me why. But basically, yes, it's working in cycle. Thanks for cycle X. Otherwise, probably just take hours for me to render this single viewport. Ha 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 ha. But yes, this is it. So and you can play around. Let's turn on this sunlight a little bit more. And then we can fold this. So the whole point of using the UV is that you want the texture to stick with the fan. Oh yes, this is amazing. And then it will overstretch. Yes, this is amazing. This is the whole point of this whole thing. And this works. Okay. Yes, so we got it. Amazing. So I think you enjoy. I hope you enjoy this. But again, this is just a temporary workaround. In the future, I think you will have all this kind of built-in attribute and set built-in attribute for just like we do with all this kind of set curve radius, set point radius. But yes, I'm very satisfied with the result currently. At least it tells me that this is possible. Okay, so I hope you enjoy this video. This doesn't actually contain many nodes. Actually, it's just this many nodes. So I hope you enjoyed this video or this tutorial. I'll probably see you next time. Bye bye.